So, we are still in Unit 1. We are still doing exponents. We are on day 5. Today, we are going to start, what do you think, Maddie? What do you think we're going to start with?
I think we're going to start with exponents. Negatives.
We are going to do scientific notation.
Oh,
Just keep your head up for me, okay?
man.
I know you're trying. If you need, stand a little bit. Standing will help keep you awake. Okay? Okay. I know I'm real boring.
For whatever reason, I've just been tired all day. I don't know why.
I'm sorry. So scientific notation. Before we even go with scientific notation, I'm going to write a number. Okay? Keep up with me.
You do not have to write this down, okay? Just relax, okay? Mr. H is gonna.
Okay.
I'm good. That's how much you guys linked in the last 10 years.
Well, that's a good number.
So, in a lot of cases with science, in a lot of cases in the real world, you will get numbers that you do not want to say, let alone write down. So, let's see. Thousands, millions, billions, trillions, don't know, 43. 43, a lot of zeros. Okay? You'll see this in science a lot with weight, with distance, with light speed, all these kind of things. You could see this number. Scientists will not write this number. And the reason why I'm using science as an example, this is called scientific notation. Scientists started to say, man, we don't want to write these numbers that are so small or so big over and over and over. There's got to be a shortcut. We all love shortcuts, right? We all love shortcuts. This number can be written as a shortcut. It's going to be 4 3/10. One decimal place is called tenths times 10 to the, and I'm going to put my finger in between the 4 and 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Woo!
Let's go.
This number here is the same as this number here. Which would you prefer to write down?
Smaller one.
Yeah, this. So listen again. This is 4 3/10 times 10 to the 40th power. Still exponents. 10 to the 40th power. It's a lot of salada, right? Okay. Scientific notation. A shortcut to write extremely small or large numbers.
How would you do the small number?
Oh, that's a great question. How would you do the small numbers? It's a great question. Love that. I love that you're thinking. So we have a really large number. In science class, you may have learned about cells, like bacteria, like all those kind of things with DNA, yeah? They are, can you see them? Can you see your cells? No, they're really, really, really small, right? We can't even measure them in inches. So let's say our cell is 0.0000000000000004 inches. That's how small it is. Like, you have to use a microscope magnified thousands of times to be able to see it. This is a small number. Yes? So how would you use it? I love that you said that. Well, I'm going to say it's going to be 4 times 10. Well, how can I get this decimal to the 4? 1, and I use what's called, yes ma'am. Go ahead.
Can't you use it as a negative instead of a positive?
A negative what?
A negative power?
Very good. A negative power. I use what's called bunny hops. And you will. You'll see me here. Get my little bunny paws. And I will bunny hop my way over. And you can be like, wow, that is the strangest thing I've ever seen in my life. I don't care. You're not going to forget bunny hops. So we're going to bunny hop. 1 bunny hop, 2 bunny hop, 3 bunny hop, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 bunny hops. But Sammy said you can't be positive because it's a small number. So with small numbers, we use a negative exponent, David. Maddie, stand up for me, honey. Okay, thanks. So scientific notation is a shortcut to write extremely small or large numbers. Shake it out a little bit. Stay awake. If you got to jump a little bit, woo-hoo, you're good. Shake it out. Okay, are you awake now?
Okay,
Huh? Yes?
I guess, maybe.
Okay, well, do a couple knee raises. I don't know what you need to do, but I mean, just kick a little bit. I'm awake.
So that's acceptable.
Okay, so scientific notation. Let's talk a little bit. Here we go. When writing in scientific notation. And this is going to be the confusing part. Our first number must be between 1 and, let me try this again. Must be, not between, let's go at least 1 and less than 10. And then in parentheses, I'm going to say can not be 10. So our first number has to be at least 1. So it can be 1, could be greater than that, but it can't be 10. So that means it could be 9.7 something, 9.9, but it cannot be 10. Andy?
5.
Yeah, 5 would be a good choice, yes. 5 would be a good choice. I like that.
Once it came to my head, like anything like 1 and through 10
Yeah.
came up with 5.
I like it. 5 is one of the possible choices. So, we have scientific notation. Scientific notation is a shorthand. You're going to see most problems written in what's called standard form. So we're going to do examples. I'm not going to really give you a lot of notes today. More examples and notes. You can sit down. So, the example will say, change from standard to scientific, and I'm going to abbreviate scientific as SCI, notation. The key with scientific notation is knowing where to place the decimal. When you're talking about scientific notation with me, we are always going to place a decimal. So here's our first example. Let's go 37,000. Now, is that extremely large to the point that we don't want to write it? No. But I still want to write it into scientific notation. It's still big enough that we can write it into scientific notation. Okay, Maddie, you ready? You'll help me out.
Sure.
Okay, when I change this to scientific notation, my first number needs to be between at least 1 but less than 10. So as I look at 37,000, we're going to use one of these numbers here to start it off. Which number has to be first?
3.
3. Because 3 is at least 1. It's 1 or greater, but it's less than 10. Now we need to say, I need to put a decimal somewhere. Where am I going to put that decimal? Andy?
Right behind the 3.
Yeah, between the 3 and the 7. I want to make it 3 and 7/10. Okay, still with me? So I've put a decimal here. And I'm going to do that. I'm going to put a decimal in my original there. Now we're talking about bunny hops. This is important. Think about a number line. Imagine a number line up here. I'm at 0. If I go to the right, am I going to my positive numbers or negative numbers?
Positive.
Positive. If I go to my left, I'm going to the?
Negative.
Okay. Here's my decimal. Right? We need to count how many places. Which way will I be bunny hopping? To the right or to the left?
Right.
To the right. So here I am, bunny hopping 1, 2, 3, 4. I've made it to the end of my problem. We went to the right direction counting. So is my number going to be positive or negative as an exponent?
Positive.
Positive. So I have 3 and 7/10 times 10 to the? How many bunny hops?
4.
4th. Yes, ma'am.
Since you can just count them
Mm-hmm.
instead of bunny hop.
If you can count them, that's fine. I really like the bunny hops to show what it is.
I was just making sure.
Nope, you're good. Okay, so, nope, you're absolutely fine. You can just count them. Let's do another one. Same directions, little bit different. Point 0.0000989. Okay, we've gotten a little bit trickier. The first question says, I need to figure out my first number. What does my first number need to be to put it into scientific notation? Maddie?
9.
9. But which 9 are you talking about? This 9 or this 9?
The first 9.
This 9. So I need to have that as my first number. So notice I'm going to draw a line right there. I'm going to put 9.89. That's where my decimal is going to go. So I'm going from this line, just like we went from this decimal, back. How many bunny hops am I going to take? So here we go. 1, 2, 3, 4, 5. Okay, I had to take my bunny tail off. Okay, so it was 5 bunny hops to which direction? To the left. We always go to our original number. So this time it's 9 89/100 times 10 to the what? Negative 5th. Yes, ma'am.
How come you don't include the 8 and the 9 in this?
Because is that part of the way that I'm going to be moving that decimal? So, if I went from here, right? Yes? I want to get back to this original number. Okay, so the question is, Isabella said, why don't you include the 8 and the 9? And I love that question. Why don't we include it? Because this times 10 to the negative 5th is saying, how can I get to the original number? So negative fifth means I've got to go left. So if I go backwards now, 1, 2, 3, 4, 5. And I plug my zeros back in. Did I get back to my original?
Yes.
But if I include the 8 and the 9, is my first number between 9 or between at least 1 and less than 10? If I had 98, would that work? No. For scientific notation, this number has to be at least 1, but less than 10. Brendan.
So does it? So this it doesn't matter what the second numbers are.
No, sir. After that decimal, it does not matter.
Mr. H,
Yes,
we had
ma'am.
a good question over here, and the question was, why do we always use 10 as the base for our exponent? And so, reach way back in your brains when we learned about place value, right? And we had ones, tens, hundreds, thousands. Mr. H was kind of counting that. Each place that we move is basically a multiple of 10, okay? So each one of these places is what we call a base 10. The base of that location in a number is multiplied by 10 each time. So this base in scientific notation
Has to be.
is always going to be 10. Can you guys remember back to place value? Nope.
So you're going to try this one on your own. I know we've only done 2. I think you can do this. So here's our third example. You're putting it into from standard form to scientific notation. 120 million. So change 120 million into scientific notation. Change that into scientific notation. So your first step is trying to figure out where does the decimal need to go. So you should be writing this down on your papers. Good, bud. Beautiful. Oh man, I'm seeing so many good answers. Oh, there it is. Yay! Perfect. Oh man. Mrs. Armstrong, it's almost like they understand this. Almost like they understand this. Okay, so, Carly, what'd you get?
I got 120 times 10
You got what?
120.
Not 120. Sammy?
1.2
I'm going to let it slide right now, but 1.2, I'm going to come back to that. Go ahead.
1 with the decimal.
1 and 2 tenths.
1 and 2 tenths.
Good.
Times 10 with the exponent of 8.
Good, times 10 to the 8th. Let's see why. First, we need to make sure that our first number is between at least 1, but less than 10. 1 is. But we have another number, it's 2, so we put that, man. There's my 1. We know the decimal has to be here, so we're going to go to the end of the problem. To the right, 1 bunny hop 2, 3 bunny hop 4, 5 bunny hop 6, 7 bunny hop 8. Which direction did we move? We move to the right, which is positive. So I get 1 and 2 tenths times 10 to the power of 8. Andy.
So you moved 8 bunny hops to the right,
Mm-hmm.
positive 8, then you got 1. I don't know this number.
Well, this is 1 2/10 times 10 to the 8th. This was 120 million. So 120 million can be written in scientific notation as 1 2/10 times 10 to the 8th because you knew that we bunny hopped to the right 8 times. Isabella, you had a question.
Yeah. So, are you basically just adding the numbers behind the decimal?
There you go. Very good. Okay, can we try another one? Yes.
Can you add a 0?
So 1 20 hundred. Yeah, I can make this 1 20 hundredths times 10 to the 8th because that doesn't change anything because that still shows I'm going to move that decimal 8 times to the right. Both of those are fine. I just don't, if it's a 0, I won't put it there unless I absolutely have to. Okay? So, let's try this one. Maddie, what's your favorite number?
8.
8. One, 2, 3, 4, 5, 6, 7, 8, 9, and then an 8. Go. Change it into scientific notation. This one's a little bit trickier. Little bit trickier. Oh, so this is our exponent. Okay, so right now I'm seeing a lot of different numbers, and I don't know. Haley, what does my first number have to be? What does the first number have to be? It has to be at least 1 and less than 10. So what's it going to be with this?
8.
8. Okay. Now, folks, this is where I want you to start drawing that line saying this is where I'm starting from. If I draw a line here, is that 8? Well, that's not where it needs to be. The decimal needs to be on the right of the 8 because 8 can be 8 and 0/10. Everybody with me? So my line's going to be to the right of the 8. Everybody with me?
Wait, what were you covered?
No, you don't have to put the line there. Nope. You don't have to. Nope, you can just have 8. But now I'm going to count. I need to go from my starting point back to my decimal. 1 bunny hop, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Most of you put times 10 to the negative 9th. But it needs to be to the 10th because where did we make the mistake? You guys started it here. That would be 8/10, not 8 as a whole number. Okay? So when we have this big long decimal, it needs to start to the right of that first number. Did everybody hear that? It needs to start to the right of the first number. Yes, ma'am.
So if you're doing negatives, which includes
The number. Yep. So just like here, we included that 9. 1, 2, 3, 4, 5. Yes, ma'am.
but if we're doing like positive, you're not including?
Nope, because it's already to the right of that number. Okay, let's try 2 more. Here we go. Last ones for the day. You're going to try them on your own. So number 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Perfect. Changing them into scientific notation. Changing them into scientific notation. Give them a try.
Staff and students, we do have internet at our phones again. Thank you to Andrew and Ben.
Thank you, Andrew and Ben. Thank you, Andrew and Ben.
Curse you, Andrew.
Oh, no.
Fix the
Thank you,
internet,
Andrew.
Dad.
You have to
Just wave your fist to the sky.
Now we're just doing.
Now we have to do work.
I can't.
Okay. Write that down first. 0.00000000000.
Okay, but doesn't this defeat the purpose? The scientific notation is supposed to keep you from writing down that big number, but we have to write it down anyway through the bunny hops.
Are you ready? There you go.
I am. This is,
All right, smile. What's your question?
okay, the scientific notation
Yes.
is to keep us from writing down that big number, but he wants us to do bunny hops,
I know.
which means we would have to write down the number.
I'm gonna give you an example, all right? If you measured the distance from Jupiter or something, it would have a ridiculous amount of zeros in it. So when scientists make that measurement, they use the scientific notation, so they don't have to write all the zeros. But at some point, they have to figure out what that measurement is, okay? But if they put it in a data table or something, your data table would be like the size of this room, you couldn't do it. So they make the number, the space the number is up, smaller. It has the same value.
Okay. Maya, where am I going to draw my line in number 1 so that I know where I'm starting?
Your decimal point gonna end up.
Between these
But
sevens.
yes, right now.
So what will my first numbers be?
Scientific, Smith.
7.75. I meant
7 and what?
and 7.
75 what? How am I going to call that? Evan?
100.
Yeah, 7 and 75 hundredths times 10 to the something. Well, we start at the line that we've made and we bunny hop. Which way are we going to bunny hop, Bianca? To the right or to the left? To the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what number do I need to put in the top? Go ahead, Isabel. Negative 11. Very good. Okay, so here we go. Moving on. Alyssa, you ready? Where do I need to put my line for number 2?
Oh,
Between what two numbers?
is up to 3 and 5.
The 3 and the 5. So I'm going to write 3 and 5/10. Which way am I going? Right or left? Don't leave. Right or left? Which way? Right. 1, 2, 3. I'm sorry. It's still my time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We will keep working with scientific notation tomorrow. Have a wonderful, safe day.